we are going to go over our hypothesis testing part 1 again. So we will have part 2 starting on Thursday. We will do also my birthday, raise the roof. So we will start part 2 then. And yeah, so that'll be a good time. All right, so let's get started by first just going and reviewing the fact that categorical variables are always going to go with population proportions, while quantitative variables always have to do with population means. Okay, so that's the main thing to remember, because we always want to make sure that you are looking at the correct situation. Like when you see something that is a categorical variable, you want to make sure that you know you're going to be using a proportion. Same thing, you know, if you saw a mean, you know that we're talking about quantitative variables, so that is important there. I literally cannot find my pen, but it is okay. All is good in the world. Okay, so let's go ahead. All right, so just to review the fact that confidence intervals and hypothesis tests are different, we want to keep this in mind because for confidence intervals, it's a range of values. So remember, we had that the lower bound to the upper bound. That's a range of between the two, and we're trying to figure out, do we think that our population parameter is within this range? But then for hypothesis testing, we're going to have one single conclusion. We're not going to have any sort of range. It's just one conclusion based upon if we think that the answer that we got is significant or not. So it's basically just seeing, you know, if we think this is useful to us or not. So when we're writing hypotheses, we want to make sure that our null hypothesis is always going to have an equal sign in it. It'll never have anything else besides an equal sign, because our null hypothesis is always claiming that there's no change going on. So that's why we have an equal sign always. And then on the other side, we have our alternative hypothesis. This is saying that there's some sort of change going on. So then these are the different types of inequalities that you can use to talk about some sort of change going on. So these are the different types of inequalities. You can say that it's less than, not equal to, or greater than. Those are the examples if there was some sort of change going on. So that's your alternative hypothesis. You'll never have an equal sign over here because we're talking about some sort of change going on. So an equal sign would not make sense over there. Okay. Okay, so statistical significance, this is when we're talking about that single conclusion I was telling you about for hypothesis testing. If something's statistically significant, we can say that the answer that we got is probably pretty useful. What we found is showing some sort of change in the population. And it's also saying it's not from random sampling error. So it's not from if you were to just accidentally find this answer, that's not what it's from. It's actually that there's some sort of difference in the population. So yeah, that's just the book definition of what a p-value would be on the probability that the statistics, so remember that's our sample, the measurement of our sample, or one even more extreme than that we found was randomly obtained from the population. So we want to make sure that our p-value is small if we want to have statistical significance, because we don't want it to be randomly obtained from the population. We want it to be actually what we were trying to find. We want to actually find a change there. So that's why we want to make sure that we have the p-value to be small there. Okay, so I'm trying to decide when something is statistically significant. The main thing we want to decide here is how big is our p-value, and then what does that mean? So like I said before, we want to make sure that our p-value is small if we're trying to find a low, or if we're trying to find statistical significance. So yeah, we always have to have a significance level that's denoted by alpha, and then often we'll use 0.05. You will often see, I said Austin, I don't even know who that is. You will often see 0.01 as another one. So those are just common ones that you can use. And, you know, they're small because we want to have those small p-values to be lower than that in order to conclude that it is significant, that what we found. So if our p-value is less than or equal to alpha, we can say that it's statistically significant. And the p-value is looked at with this conditional probability down here. If you remember from our probability unit, we would read this as the probability of rejecting the null given that the null is true. So remember, this line is representing given. That means that this right side has to be true first before the left side is true. And in hypothesis testing, we do always assume that the null hypothesis is true until we find out otherwise. So that would be if we find out that there's statistical significance and there is a change in the population. So, all right. So when we're interpreting our p-value, so we just talked about, you know, if it's smaller, if it's larger, whatever, but what does that really mean? So let's say that our p-value is greater than alpha. Like I said, we don't want it to be greater than alpha because then we're not going to be able to conclude statistical significance. So when our p-value is greater than alpha, we're going to basically keep that assumption that our null hypothesis is true. We're assuming that there is no change in the population based upon what we got. So we're going to fail to reject the null. So we're failing to say that we think the null is wrong. Kind of got to wrap your head around that one. And so yeah, we can't conclude that there's any sort of change because we are failing to reject the null. We're not accepting the alternative. Some people get that mixed up. We're not accepting the alternative. We're just saying that we don't have evidence to say that the null is not true, because remember, we're always assuming that it's true. So if we assume that it's true and then our p-value is greater than alpha, then we're not going to be able to reject that. We're just going to keep that assumption there. Wow. Why are we already on reviews? That was really speedy. Am I talking fast? Oh, I'm sorry. Okay. All right, let's go ahead and do some reviews, I guess. Okay, I was going to say, I feel like I just sped through this. This one, I guess, isn't, I feel like last semester we had hypothesis testing together in one unit, which is why I feel like this is going fast. But like I said, we split it up, so we will have part 2 on Thursday. So get excited. But okay, yeah, you're right. I know, I just didn't think it was this short. I was like, what the heck? But okay, all is good. All right, so let's try this review question. So in a two-tailed hypothesis about a population mean with a sample size of 100 and alpha equaling 0.05, the rejection region would be what? So go ahead and try this one out and let me know what you think. Okay, cool. Yeah, so absolutely. So our answer here is going to be C. So let's discuss why it is C. Great job, Maria. So let me get my little pen up here. Okay, so remember, so this is two-tailed, which means that we're talking about not equal to. That's what the representation of two-tailed would be. So in this case, if we're talking about the hypothesis about population mean, a sample size of 100, n equals 100, kind of irrelevant in this case, but make sure you pick out all that information. And then our alpha level is going to be 0.05. And then, so what we want to think about, so our alpha level is talking about the part of our curve that is going to be our rejection region. So since this is two-tailed, we want to keep in mind that we're going to have a point down on either side. We're going to have a point here and a point here that's representing the two different points that are going to show like our rejection region. So if alpha is 0.05, that means that our rejection region has to be equal to 5%. And in this case, we have a rejection region over here and then over here. So we technically have to split it up. So this is going to be 0.025, 2.5%, and then same with over here. And then so together, it's going to make 5%. So this is our rejection region. We have half of it over here, half of it over here. So remember, so this is going to be 95% in here then, if, we're adding this up and it's going to equal 5%. This is going to be 95%. Here's it is in a decimal. And if you remember from the empirical rule that that 95% of the data lies within plus or minus 1.96 standard deviations of the mean. So that's why we're able to put negative 1.96 down here, and then 1.96 positive here, because we understand the fact that between 1.96 standard deviations from our mean is going to be 95% of our data, which also corresponds with 5% of our rejection region for a two-tailed hypothesis. Our answer is C. Does that make sense to everyone? Yay. All right, cool. Yeah, I know. I seriously, I love the empirical rule. If I could have a poster on my wall, I would. It's a great time. It's very applicable to everything. So definitely that's something to keep in mind and just kind of review, because you will see it often. Because and it's a way you should be happy if you see something that's like 68% or 95 or 99.7, because you already know how many standard deviations from the mean it is. So that's very helpful there. But all right, great job. All right, another one. A researcher claimed that feeding cows half a pound of bananas every day will help them lose 8.5 pounds. That's crazy. After 1 month of treatment, if we want to conduct an experiment to determine if the cows are losing less weight than advertised, which of the following hypotheses should be used? Go ahead, read through these options and let me know what you think. All right, great job. You guys are geniuses. That's absolutely correct. So let's look at this. So we have, so remember, our null hypothesis is always going to have an equal sign, okay? Always has equal sign, okay? So we can already cross out D and E because it's saying the null is not equal to. That's no bueno. We don't want that. So D and E can't be it. And then we have, so we're up to A through C. So in this case, the null, they're all true. They all, are accurate in terms of this question. But then our alternatives is what we got to look at. So in this case, it said they want to conduct an experiment to determine what if the cows are losing less weight than advertised. So our mu has to be less than 8.5. So that's why C is our answer. This also can't be the answer. It's saying the alternative hypothesis is equal. you can never have an equal sign in your alternative hypothesis. And then A would be correct only if it was saying if the calves are gaining weight, greater than 8.5. So then our answer is C there. Does that make sense to everybody? All right, awesome. Let's clear this. Alrighty, let's see what we got. Okay, a hypothesis test is done in which the alternative hypothesis is that more than 10% of the population is left-handed. P-value for the test is calculated to be 0.25. Which statement is correct? So go ahead and read through these options and let me know what you think the answer is. All right, great job, guys. So let's go through this. So remember, if you aren't given an alpha level, we usually just assume that it's 0.05, 5%. So that's what we're going to do in this case. That's what we're going to assume it to be. That'll be our rejection region. So it's saying the hypothesis, the alternative hypothesis, is that our P is going to be greater than 0.1. So because it's more than 10%. So and our p-value is going to be, so p-value is equal to 0.25. And in this case, 0.25 is going to be greater than 0.05, which is our alpha level. So this means that we're going to fail to reject the null. Okay. So that says null. All right, so since we know that, basically in this case, we're saying that we're failing to reject the null. We're still going to assume, we're keeping the assumption that HO is true, that the null is true. So in this case, if our null is that the proportion is equal to 10%, we're assuming this is true. So A says we can conclude that more than 10% of the population is left-handed. That's not true because if we were concluding that more than 10% was left-handed, our p-value would have had to have been less than 0.05. So that can't be correct. B says we can conclude that more than 25% of the population is left-handed. That's if you would, mix up the p-value and our population or a sample proportion there. And from the population, so that's not correct. And same with C. This 25% has nothing to do with our proportion that we got. So D has to be the correct answer. So it's saying we can't conclude. I was not trying to cross it out. We can't conclude that more than 10% of the population is left-handed because we're failing to reject the null. So in this case, we're basically saying that we are assuming that the null is true at this point. We can't say anything about the alternative in this case, so we can't conclude that. So our answer is D. Does that make sense to everybody? Yeah, definitely. I know the wording is confusing. So that's one of those things that the more practice you do, the more it's going to make sense. Honestly, like it just kind of clicks, at one point. I know a lot of people have that epiphany sometimes, they're working through and it's like, oh, okay, that's what they're trying to say. And the more and more you practice and the more you try to put in your own words and you listen to other people talk about it and word it, then that's probably going to help you out because you'll be able to say it in your own words that makes the most sense to you. So yeah, perfect practice makes perfect. All right, one more, I believe. Okay, so just a quick review here. So true or false, if our probability or if our p-value is greater than alpha, we reject the null hypothesis in this case. I should say p-value, not p. I don't want that to confuse you. Yep, great job. So this is false because if our p-value is greater than alpha, we're actually going to fail to reject. So if you remember from the last problem, our p-value was like 0.25, and then our alpha, which was greater than our alpha, which is 0.05. So that's why we failed to reject our null hypothesis. So good job, you guys definitely understood that one. Alrighty. Okay, so that's all we got. Sad. So obviously you can go ahead on the YouTube channel. Everyone has access to that. I'm hoping that's on the you can go to the Review Session Central page on the Stat 200 notes to go ahead and check those out. Our next group review is going to be on Thursday, the 28th at 10 again. And that'll be for the second part of hypothesis testing. So if you have any more questions, go ahead and type them in the chat box. If you haven't given me your Penn State ID, your email, go ahead and put that in too. And if you're good, then you are good to go. So thanks for coming, guys.